Hey guys, we're going to review quiz 3 right now. That way, if you weren't in class the day that we reviewed it, you can watch this short video to help prepare you guys for your upcoming exam. So first question, you're given two functions, f of x and g of x, and we're dealing with composition of functions and analyzing their domains. We want to find f of g of x and its domain, and then make sure you read the entire question. You want to simplify your answer, and then you want to write your domain not in inequality form, not in set builder notation, but in interval notation. Okay, so let's get started. We are going to, because we're taking f of g of x, we want to look at that outside function, which is f of x, and wherever you see an x in f of x, you're going to just draw big, giant parentheses. And then inside those parentheses, you are simply going to put in your g of x, and I'll color code so you can really clearly see what's going on here. So inside those parentheses, we have our square root of x plus 2. And that's it. Now you just have to simplify. So square root of anything squared is just what's inside. So we get x plus 2 plus 1, combine some like terms, and you get your f of g of x to be x plus 3. And we're done. So that's the first part of this question, finding that composition. The second part is we want to analyze what the domain of this composition is. And you want to be careful here because you don't want to just find the domain of x plus 3, which we're dealing with a linear function. Domain is all real numbers, negative infinity to positive infinity. We want to look at the intersection of the domain of x plus 3 and the domain of the input, which in this case is our g of x, square root of x plus 2. So we kind of did half of it already. We know that the domain of x plus 3 is just our all real numbers, negative infinity to infinity in interval notation. But we also want to find the domain of our g of x, which is square root of x plus 2. And anytime you're analyzing a domain, what two conditions do you want to think of? The first one, your denominator cannot be equal to 0, because if it is, then we're looking at an undefined function. So we want to figure out, okay, what are values of x that make it equal to 0 so that we can restrict those from our domain. And then our second condition is we don't want to have any negative values under even roots. Square root, quartic root, sixth root, so on and so forth. Lucky for us, that first condition doesn't apply here because we're not dealing with fractions. So we just want to hone in on that second condition, which means we want to look at this x plus 2, and we want to set that greater than or equal to 0. Inverse operations tells us that we're going to subtract 2 from both sides, and we're looking at all values of x that are greater than or equal to -2. In interval notation, this is just hard bracket -2, comma, infinity. And so we're almost done. We want to look at, okay, well, what is the intersection between -2 and infinity and all real numbers? Well, it's just -2 to infinity. So the domain of this composition function is -2 to infinity, and a hard bracket at that -2. It's really, really important that you identify that input domain, because if you don't, then you'll end up choosing values that could possibly not be part of the domain. And I know a lot of students are like, I don't understand. Why don't you just find the composition and look at that domain? Because technically we are just looking at x plus 3 when you compose it. Yes, you have a point there, but based off of the question itself, you're factually given these two functions, which means you need to take that into consideration when you're looking at that input function. If you end up choosing an x, I don't know, x equals negative 100, that will not even suffice here because negative 100 plus 2 is negative 98. And what's the square root of negative 98? Oh, we're in the imaginary world now. Okay. Now let's go ahead and look at part B of this problem, where now instead of finding f of g of x, we're finding g of f of x. So I'm going to go ahead and write these functions again down here so I don't have to keep scrolling up. Our g of x is equal to our square root of x plus 2, and then our f of x is equal to x squared plus 1. So now our parent function, aka our outside function, is going to be our g of x, which means wherever you see an x with your g of x, you're going to go ahead and put in big giant parentheses. And then inside those parentheses, color code so you really see what's happening here. But inside those parentheses, you're going to fill in your f of x. And your f of x, screen, and let's use blue, is your x squared plus 1. And so that's it. This is your g of f of x. You just want to now simplify it. So we can get rid of these parentheses, and we're looking at x squared plus 1 plus 2, square root of all of this, which is essentially just the square root of x squared plus 3. We cannot simplify this further. So we did the first part. Once you get to this part, you already received half credit on this part. Now let's look at the domain. So again, intersection between the composed function and its input. So we have the domain of the composed function. We want underneath that square root has to be greater than or equal to 0, which means x squared has to be greater than or equal to negative 3. And any number in the entire real number system in parentheses squared is always going to shoot to what? A positive value. And so do we have any restrictions here? No, we have no restrictions, which means our domain is just all real numbers. Negative infinity to infinity. Lastly, let's look at the domain of the input, which is our f of x here. And our f of x is just our whole x squared plus 1, which is a quadratic function with a vertical shift up 1 unit from the origin. Do we have any restrictions here? No restrictions. So what are we looking at? Once again, our domain is negative infinity to positive infinity, aka all real numbers, which tells us that what's the intersection between all real numbers and all real numbers? We have all real numbers. And that's it. So that concludes our first question. Again, feel free to stop, pause this video, rewind if I'm going a little too fast. And let's move on to the next page. So question 2 is a lot more straightforward. we are given two graphs, and we just want to analyze these graphs based off of what they're asking. So finding computations. We have our F, and then we have our G. So let's analyze the input. And then once we find that numerical value, then we plug it into that outside function. So G of 3, when our X is 3, what is our Y for our G function? It's 4. So essentially we're looking at F evaluated at 4, which now let's move on to our F of X graph, and we just get 0. We're done. Easy enough. Part B, F of 1, we have is 3. So we're just looking at G of 3. And when we evaluate that, what do we get? We get 4. And we're done. And last but not least, we have our last question for today, which is a word problem and trying to find its composition. So a forest fire leaves behind an area of grass burned in an expanding circular pattern. Okay, what's the area of a circle? Well, the circumference. Cherry pie is delicious. Circumference equals pi times diameter, also known as 2 pi r. Area, apple pies are 2, area equals pi r squared. We're given if the radius of the circle of burning grass is increasing with time according to the formula. So we have our radius in terms of function notation, 5t plus 1. We want to express the area burned as a function of time, t minutes. So we're essentially looking at A of R of t. So wherever you see an R, draw some big giant parentheses, and then inside those parentheses, fill that in with our 5t plus 1. And that's your answer. You can simplify. If you FOIL it out, you end up getting 25t squared plus 10t plus 1 all multiplied by pi. I would accept that answer. And then if you wanted to distribute the pi, you get 25 pi t squared plus 10 pi t plus pi. And I would also accept that last answer. That's it. So this completes the quiz. Let me know if you have any questions. And I hope that this is helpful with studying. Take care.